The first part of Chapter 18 Lab is about hematocrits and viscosity. Make sure you read the section in the book about hematocrits. So this is in the beginning of the chapter where it talks about blood composition. Remember, blood is number one, plasma. That's the most abundant thing in blood, which is the liquid part. Then the second most abundant thing is the red blood cells or erythrocytes. That makes up most of the blood. Only about 1% of the blood is the white blood cells and the platelets. So a hematocrit is where you see what percentage of blood is red blood cells. And the way you do this is you get some blood and you put it in a test tube and then you spin it in a centrifuge. The red blood cells are heavy, they're the solid component. So spinning it makes that heavy part go to the bottom of the test tube. The liquid, the plasma, is lighter and it rises to the top. And these are just little sucker sticks that I bought in the craft section, and I used a marker to make them look like a hematocrit tube. So in real life, you would have a test tube of blood, you would put it in a centrifuge, and the red blood cells would go to the bottom, the plasma would be at the top. There's pictures in your book of what this looks like in real life. Then all you do is see how much total blood there is, the plasma and the red blood cells together, how much of it is red blood cells, and you divide to get the percentage. So the math is really easy. If you put this here, you can see that the tube is 10 centimeters altogether. So the total blood in this tube is 10 centimeters. You can see that the red comes up to the 5. So you have 10 centimeters of total blood, you have 5 centimeters of red blood cells. So 5 out of 10 is 50%. So this test tube has a 50% hematocrit. So you calculate the hematocrits the same way for the others. Here's tube B. You would just put it on here. You see the total is 10. You look at how far the red comes up, and you divide. So this one has a 40% hematocrit. Here is C. This time you figure out the hematocrit. And here is D. Okay, the next part is viscosity. So there is a relationship between hematocrit and viscosity. So I used some red sugar, like from the baking section at the grocery store, and corn syrup. And I have these little cups that have marks on them with numbers. So to get a 40% hematocrit, that means that it's 40% red blood cells and 60% plasma. We're not going to worry about that 1% that's the white blood cells and platelets. So in this cup, I put red sugar, which represents the red blood cells, up to the line with a 4. Then I put corn syrup up to the line with a 10. That gives me 40% red blood cells and 60% corn syrup, or plasma. The other one, we want a 60% hematocrit. So that means 60% is red blood cells. And it always has to add up to 100%. So 60% is red blood cells. The other 40% is plasma. So in this cup, I put the sugar, which represents the red blood cells, up to the line with a 6. Then I put the corn syrup, which represents the plasma, up to the line with a 10. So now I'm going to stir these up to get them mixed, and then we're going to pour them out to see what their viscosity or thickness is like. So here I stirred them up and I poured them out onto a piece of paper. You can see the 40 and the 60. And if I lift this up a little bit so that gravity can kind of start to act, there you can see what's happening with the 40 and what's happening with the 60. The 40 is running down, the 60 is a little bit, but the 40 is definitely winning. So the thicker something is, the less it's going to flow. You can see the 40 is flowing better, The 60 is wanting to just kind of sit there. So the 40 has a lower viscosity, the 60 has a higher viscosity, and that affects how well blood flows.